All right, so we're all going to have our own different methods of doing these, and I appreciate that. But what I'm trying to show you, the most effective method in order to get it right. And of course, that doesn't mean that my way it's my way or the highway. You do it your way, but bearing in mind that you might want to consider doing it my way if you're making mistakes. So first of all, what I would do here is we're solving for this equation, and I'd be expanding the brackets first. So I've got 6x minus 8 is equal to 10x plus 5. I then want to look at which value of x is greater. Well, I've got 10x. I'm going to leave that by itself, and I'm going to subtract 6x from both sides, which is going to give me that. And then I want to subtract 5 from both sides, so I'm going to have negative 13 is equal to 4x, and therefore x is equal to negative 13 on 4. Can I get a show of hands of students that got that correct? Good. Now, just quickly over here, a number of students, you could, if you wanted to, find like denominators for each of these, but you don't need to. It's only when you're adding them. Okay, and if I've got an equation or a fraction on both sides, then you don't need to worry about it on the left-hand side. However, I would deal with the right-hand side first. I need a like denominator, in this case 10, which means I've got to multiply both sides by 10, which means that would become a 90. Now I'm going to expand the brackets on the left-hand side. 2 times x is 2x, 2x plus 4. I probably could have left that alone, but I'm going to expand it. That's what I would just do naturally. Is equal to 5 is equal to 90 plus 2 minus 2x over 10. Now, don't go trying, and a number of you tried to find a like denominator on the left-hand side. We just can cross-multiply. But at the same time, I'm going to simplify the right-hand side first, just to make my life a bit easier, and my Surface Probe all of a sudden is... okay, I lose it every now and then. 92 minus 2x over 10 is equal to... I might leave that as, 2x plus 4 over 5. Now what I might do here is... and if you did this, you probably find... Remember, we want to find a common factor. Let's find a common factor of 92 and minus 2x. What would that be? 2. We'll just say 2 for the time being. So that's going to give me 46 minus x over 10 and 2x plus 4 over 5. Now, of course, on the right-hand side, I can do a bit of cancelling, can't I? Because 2 goes into 10 5 times. So that's a 1, that's a 5. And we could actually, I've got a fraction equals a fraction. If you like, I can cross-multiply, but in effect, what happens? Those 5s cancel out, don't they? So because I've done that, I've made my life a lot easier. If you did cross-multiplying, all of a sudden you have to multiply 5 by 92 or something like that. And then, of course, you can work it out, but you can make mistakes. You're more likely to make mistakes, aren't you? So what have we got left? We've got 2x plus 4 is equal to 46 minus x. I'm going to look at the greatest value of x and leave that alone. I'm going to add x to both sides, which gives me 3x plus 4 is equal to 46. 3x is equal to 42. X is equal to 14, if I'm dividing both sides by 3. Hands up if those of you got that correct. And yeah, you had a question?
Would this be on the part, like that sort of question, would it be on the part where there's no calculator or a calculator?
No calculator. Okay. All right, good to see, but I reckon there would have been a few mistakes there, which is good. At least let's make those mistakes now. Now, just quickly over here, remember when there's an inequality, don't worry, it's still the same. You can almost pretend as though it's an equal sign and you can deal with it at the end. But don't be scared of it. I'm not going to change it to an equal sign. I think some of you might have, but I think the first thing is we've got two fractions. We're adding or subtracting them, so I need to say that the LCD of 3 and 9 is 9, isn't it? Is equal to 9. So I don't need to do anything with this fraction. But what I will say is I've got to multiply x plus 5 by 3. And I then have this. Now be careful. This is where a lot of you struggled. We've got a negative out the front. Let's do a bracket here. That might make it a bit easier. 2x minus 1. Because you can see there that that negative is going to carry across. Well, that's an electric circuit thing from physics. We don't need that right now. Okay, so over 9 is less than or equal to 5 over 18. You can change it to equal sign if you want, but you don't need to. Let's just pretend it's an equal sign and write an inequality. So now what we do is we expand the brackets, which is 3x plus 15. Now, minus 2x. Yes. Negative times a negative, though, is positive 1, which I think quite a few of you might have made that mistake. I'm not saying you did, but I think quite a few of you might have. All right, let's have a look now. 3x take 2x is x. 15 plus 1 is 16. X plus 16 over 9 is less than or equal to 5 on 18. Now, I could cross multiply if I wanted to. There's no issue with that. I don't think that I will do that. I'm going to cross multiply, and again, my computer is lagging behind. So I've just got to wait for it to, yay, 18. X plus 6 is less than, 9 times 5 is 45. Let's carry that across. 18x now, 6 times 10, 60, that's 108. 108 is less than 45. And now let's subtract 108 from both sides, which is what? Negative 63?
Yeah.
Yeah? Will you take me? Yeah, you're okay with that?
Yeah.
All right, good. 18x is less than 10. That's an equal sign. 45 take 108 is negative 63. So therefore, x is less than, and I'm not dividing through by a negative number, so I don't have to change that sign, do I? So x is less than negative 63 over 18. 63, not a prime number, but we can, well, I guess 21 does go into 63 3 times, so I could divide both sides by 3, couldn't I? Yeah. I could divide this by 3 if I was simplifying. X is less than or equal to, well, which gets us to negative 21 over 6. And I could divide both sides by 3. So 9 goes into 63 and 18, doesn't it? And it goes in negative 7 times over 2. Now, who in this class either got this or this? Not too many? Yeah, well, there's a mistake in there. Yeah. Negative 13.5. That's 9 goes in there twice, 9 goes in there 7 times. That's the answer. All right, so Lorenzo, did you get that answer?
Yeah.
Yes. Yes. Did you have a question?
Just really quickly.
Yep. All right. This is 16, isn't it? There you go. So I've done it right according to it being 6, but it's 16. So this here we need to deal with again, don't we? So 18 times 10 is 180. 6 times 18 is 200. So the answer is?
Negative 27 over 2.
Yes.
So Lorenzo got it wrong.
It helps to get 16 and then to make that a 16 as well. Okay. Thank you. I told you I make mistakes.
In the videos.
In the videos in particular. All right. We're moving on. First of all, I'm adding these three things with algebraic fractions now. LCD for these is 24. LCD is 24. So, what that means is I am multiplying x by 12, and I'm multiplying 3x by minus 4 by 3, and I am multiplying that by 8. Be careful with the brackets, please. I would add a bracket in there where that negative is. That's 24, and that's now 24. Now we can do a bit of simplifying, can't we? We can say that 12x plus 9x minus 12 minus 48 plus 8x over 24. Now what does that give us? Have we got 29x? 29x, it's 29x minus 60 over 24. Nah. You could separate it. You could separate it, but I would accept that answer. So if you did this,
I told you it was 29x.
and 60 over 4, 4 goes in there 15 times and 6. 3 goes into 6 twice. 3 goes 5 over 5 over 2. You could split that up, but I would still give you full marks. That's, if you ask me, this is simplified. Okay? We carry on, because I do need to get through some of these other ones, which you will find tricky.
29x.
First of all, I'm going to 3x by 2xy is 6x squared y, and 9 by 8 is 72. I'm doing this, that and that. Okay? Now I've got divide by 3y over 4, so I've done the left-hand side. I've done this part first, which would make sense to me. But 6x squared y over 72. I'm going to change that divide, the old flipperoonie, like so. Now, I can do some cancelling here. I don't care how you do the cancelling. Just for me, I'm just going to say, all right, 6 goes in 6 and 3. That changes that to a 1 and a 2. And then a 4 and a 72, I can say, well, I'll just say that a 4 goes into 72. I happen to know that goes in 18 times. Okay, as you do. Or maybe you could say, maybe you could have done the cancelling. 2 goes into 72 36 times and done it that way. Either way, you say potato, I say potato. That's fine. You absolutely can cancel the y's out. So what am I left with? X squared over 9. 2x squared over 18, which is x squared over 9. It's not x over 3. It's just it's x squared. Yeah. No, you can't do that. You can't square root because you don't have an equal sign. You don't have an equation. We've just got this and we're simplifying it. Now, wait. I'm sorry, I'm not waiting because we've got 17 minutes left of class and I've got a fair bit to get through. You can watch the video. Now, find the equation of the line passing through these points. Now, I would do it this way. I would say y equals mx plus c is a line. I've got 2 points. I can say that m is equal to my rise over run, which is this, y2 minus y1 over x2 minus x1. But before we do that, let's give them the old label. x1, y1, x2, y2. Remember that the point on the right needs to be the point with the higher x coordinate. Sometimes they can be mixed up. So I'm going to go, and of course it's important where we deal with our negatives. 1 minus 1. 2 minus 2. Now we know that this point, if you were to plot those 2 points on a Cartesian plane, you could see that it's going to have a positive gradient. So if you do get it mixed up, be careful. Make sure you think about it before you go ahead and just write that your answer's a negative gradient. Consider that you might have made an error. 1 plus 1 is 2. 2 minus minus, or 2 plus 2 is 4. So therefore we've got y equals 1/2 x. But it is a half x plus c. We don't know what c is yet. However, we can say when x equals, I'm going to pick one of those points that's on the line, when x equals 2, y equals 1. So let's throw that in there, 1/2 times that plus c. And look at that, we've got 1 is equal to 1 plus c. Therefore, c is equal to 0. So my equation is y equals 1/2 x. Okay, good. Now midpoints, we looked at them last year. We sort of made an assumption. Last year we had it in the questions, I think. This year we didn't. But M is the midpoint of AB. Now, remember that we said that a midpoint is equal to, if you like, add the coordinates and divide them by 2. Add the x coordinate and add the y coordinate. That's what we did last year. In other words, it's like finding the average, isn't it? Now this is x1, this is x2, this is y1, this is y2. So the easiest way to do that, we can say that m is, the x coordinate is -3 plus 5 over 2. Not that bad. -2 plus 4 over 2. That's shown me enough, if you ask me, because I do realise that 2 over 2 is equal to 1, and 2 over 2 is also equal to 1. Now, just quickly, it says here to show. So make sure that you show your steps. If you write out just the answer, you won't get any marks because you haven't shown anything. We've given you the answer for flipping sake. Okay? You must show the answer. You've got to show something. Now, find the distance from A to B. Now, a lot of you are going, oh my God, we haven't learnt that. Well, hang on a minute. I've got coordinates here, don't I? Doesn't that make a triangle? Hallelujah. Okay, so -3, -2, is that coordinate? B, 5, 4. Now, in other words, my rise, or this distance, is going to go from -2 to 4. You don't have to do 4 minus -2. To go from -2 to 4 is a distance of 6. And to go from -3 to 5 is a distance of 8. And we, of course, want to find what that is. So in other words, the distance from A to B, good, we do use Mr. Pythag. So that is a distance of 8, that is a distance of 6, and we can say that, if you like, AB squared is equal to 8 squared plus 6 squared, which is 64, plus 36, which equals 100. And we want to do the square. We don't want AB squared, we want AB, don't we? AB is equal to the square root of 100, which is equal to 10. Thank you. Now, find the gradient of the line through AB. Hopefully this stuff is all okay. Find the gradient of the line through AB. Well, yeah, well, we've just drawn a triangle here. So isn't the gradient M is equal to rise over run, which is y2 minus y1, but I've just drawn a triangle, and I can see that the rise is 6 and the run is 8, but I wouldn't go ahead and leave it like that, because 2 goes into 6 3 times, and 2 goes into 8 4 times. Yes?
If you just wrote 3 divided by 4 and would you get 4 marks?
Yeah, you would, because it's worth 1 mark. 1 mark generally means no method. However, when it says show that, there is a method, okay? Because clearly you've been given the answer. It's not very fair. Oh, here's the answer. Here's a mark. You've got to show something. Write down the equation of the line parallel to AB. So therefore, we know that the line parallel to AB, in other words, this line must have an equation, we'll call this M2, has to have the exact same gradient, doesn't it, if it's parallel? So M2 equals 3 on 4. So I'll say that my line is 3 over 4x plus c. We need to find out what c is. But guess what? Doesn't that indicate that it's the y-intercept? Isn't c the y-intercept in a graph? Yeah? Can you see that? That x equals 0, y equals 5. What? Oh, yeah. Okay, c is equal to 5. It was just a silly laugh, you know.
Best laugh I've ever heard.
All right, so far, hopefully so good. Make sure that we're talking parallel, same gradient. Perpendicular, that's a little bit different. Because now it's saying write the equation of the line through M perpendicular to AB. Now, what is the gradient of AB? If it's perpendicular to AB, first of all, I'm getting a bit of lag here now. Okay. If I have y equals 3/4 x is 3/4 x the gradient of AB, the distance of AB. If that's the gradient of AB and it's perpendicular, I can say that my new gradient of my perpendicular line times by 3/4 is equal to what?
1.
-1, thank you. Now, I could rearrange for that. Now, if you like, remember how we said that you could do the old flipperoonie and change the sign? Yeah. So I've got 3/4. What can I do? I can change that over and I can say that's -4/3. Okay? But, of course, if I wanted to solve for M2 here, I can multiply by 4, I can divide by 3. That's going to give me M2 equals -4/3 anyway. So you do it my way or your way, up to you, however you prefer. Now it says write the equation of the line of M perpendicular with a y-intercept. So therefore we know that it's -4/3 x, and guess what? We've been given c again, haven't we? Plus 7/3. Otherwise you could have said that this was plus c, and then you could have subbed in this point, but really you could have skipped a step there, couldn't you?
Yes.
Because c is the y-intercept. It always is in a line. Show that c lies on the line. Now c is the coordinate this. Okay, so we've got to refer back to that. 13 on 4 minus 2. So, showing that lies on the line. When x equals... Is it 13 on 4?
Yeah.
Y equals -2. Is that what's supposed to happen? Yeah. So let's show it. Show that C lies on this line. So we needed to get this answer correct. So we needed to get... let's just show and sub in. So we've got -2 is equal to -4/3 times 13 on 4. Plus C, which is plus 7 on 3. Now, what we can do then is we can cancel out these 4's, but remember that the negative doesn't go anywhere. -2 is equal to -13 on 3 plus 7 on 3, which is equal to negative 6 on 3, which is equal to negative 2. What can we say about these two statements? Does the left-hand side equal the right-hand side?
Yes.
So we can therefore say that this is true. Hence, we can say that C lies on y equals negative 4/3 x plus 7 on 3. Okay? Probably not as bad as you think, a lot of this stuff. But a lot of the time when you're looking at it, it's the interpreting of the question. Now, just quickly, I've got two graphs and they intersect at this point, and of course your calculator can do all this. Remember, in the second part of your test, you have a calculator, don't you? So you can use it if it helps you. Give the set of inequalities that will denote the area of the triangle between the two lines and the x-axis. That is this, ladies and gentlemen. Look at this. We want this triangle. Now, remember that first of all, we have to establish which one has the higher gradient. 2x minus 2 or a half x plus 1. So therefore, would you agree that this slope here is greater? So this one must be the 2x minus 2 one. Okay? Now, that's really important to know. We can't get them mixed up. This is the 2x minus 2 one, and this is a half x plus 1. Now, what we need to do then is think about it. If I wanted to have the area, we need to have more than one. Now, this is a tricky one. We want above this line, don't we? We want above that line. Would you agree?
Yes.
So, would you say that we want it to have y is greater than or equal to, it's got to include that line, y is greater than or equal to 2x minus 2. And, though, so we're looking at a region, so that's going to give us everything. But what we want to do is we also want y is less than or equal to a half x plus 1. Now what's that going to do? A half x plus 1 is going to give me all of this region here. Okay, so that's going to give me all of that region. And, of course, if I did it in blue, this is quite funky, this. When I do this, let's... Oh no, actually there's a different colour. Ready for funkiness? Yeah.
Glass colours.
Oh my goodness. Mind blowing.
Are you copying the whole thing?
No, we're not. It was supposed to be a different colour. Okay, this. What we want. Yeah, let's. I did too much colour. Just a bit too much. All right. I got a little bit excited. But what would happen if I had those two inequalities, and we also have another one, because x is greater than or equal to 0, isn't it? Because we're talking about and y is greater than or equal to 0 because it's between the x-axis. Okay? That is actually going to give you that region there. Sorry? Yes, that's going to give you that region. So it's 3 inequalities. This was a tough one. A lot of students really found that hard. Yeah. So that was a tough one. Now, now just quickly before we go, find the area of the triangle. Well, first of all, the area of the triangle. Let's have a look at the triangle. We've got negative 2, 0 is this thing here. We've got that this. Oops. That is 1, 0. That has a coordinate of 1, 0. That has a coordinate of 2, 2. Now, we've got to find the height of that triangle. Area of triangle is base times height, isn't it? Now, the base is actually this distance here to this distance here. So I'll give you a bit. Yeah, but then the problem is that you do that, then you have to find that height there.
Oh, because it's not straight.
It's not a straight line, is it?
No.
So that's why we need to actually find this is the height. Okay? So my hint to you is use Pythagoras' theorem to work out that length.
Oh, it makes sense.
And then that length there to that length there, you could also do the same. Because that is a triangle which is 1 by 1. That is going to have a height of √2, okay, using Pythag, and that's my hint on how to do that. Now, unfortunately, I couldn't get through the last sort of question or so, but at least that gives you some basis. Watch those videos over the weekend is my advice to you. Have a go at any additional resources on Connect, and add to your bound reference. Remember, you can put in as much in there as you like.
Is it just on linear relations test?
Do you have a